Okay, good morning, everybody. So just to quickly remind you where we were last day, we were talking about implementing the comparable interface for our point 2 class, or for any class for that matter. So when you implement the comparable interface, you're doing so because you want people to be able to sort collections of your, collections of objects of your class. So when you implement the comparable interface, you have to provide this method called compare_to. Right? And remember, compare_to returns a negative value if this object is less than the other object. It returns 0 if this object is equal to the other object, and it returns a positive integer if this object is greater than the other object. So compare_to is essentially less than, greater than, and equal to for objects. If we want to compare points by their distance to the origin, then implementing the method's pretty simple. Right? So I want to know if P, so when you write P dot compare to Q, right, you want to know is P less than, greater than, equal to Q. Right? And remember, inside the method, P is this, right? And Q is going to be other. Right? So Q is our parameter, and inside the method, P is just the method, inside the method, the object that was used to call the method is called this. Right? So it's pretty simple. You just compute the distance to the origin for this point, compute the distance to the other origin for the other point, compare the two distances. Right? And you can come up with this little method here. Right? Now remember, when you implement the comparable interface, you have to say that you implement the comparable interface. So you have to write implements comparable, and then you have to specify the type of thing that you want to compare to. Right? So in the point 2 class, we're comparing to other point 2 objects, so that's why that's point 2 there. Then you implement the compare_to method. Right? Compare_to method always has the same signature. Right? It's public int compare_to, and then the type of the object that you're comparing to. Right? And so compute the distance using hypot, right, which is the hypotenuse function, and then compare the distances. Right? You can write an if statement if you want to, but in general, you should avoid writing the if statement and just use one of the wrapper classes to do the comparison for you. Right? So if you're comparing two double values, just use double compare. If you're comparing two int values, just use integer.compare, and so on and so on. I guess if you're comparing two reference values, you would have to use the compare_to method for those reference values, assuming it existed. If it didn't exist, then you have another problem. You have to figure out how to compare the two objects. Okay, so this is where we got to last class. We were about to talk about what the actual contract for compare_to, what it actually reads. So if you read the contract for compare_to, so just look up the documentation for the comparable interface. You'll see that the definition is fairly, the documentation is fairly mathematical. So in other words, it spells out what it means to be, what it means for something to have a natural ordering. It's not that important to go into all the nitty-gritty details of that definition right now. But what you need to know is that when you implement comparable for a class, it's supposed to be the case where every unique object of your class can be put into some sort of, has a certain order. Right? So for the integer values, there's a smallest value, there's a largest value, and all the other values go in between. Right? For the double values, it's the same thing. Right? There's a negative infinity, there's positive infinity, and then all the other values go in between. And for the double values, it's actually it's slightly more interesting because -0 always comes before +0 if you use the double.compare method. Right? If you just use less than or greater than, then -0 is not less than and it's not greater than +0. So if you implement compare_to using less than or greater than, then you could be inconsistent with the way that the Java standard library implements it. What is in the contract, though, that's important to talk about is what's called consistency with equals. So the documentation says that you should try to be consistent with equals when you implement compare_to. And what that means is it means two conditions have to be true for compare_to to be consistent with equals. Right, so if you remember from your math classes, this is basically if and only if. Okay? So if x compared to y returns 0, then it must be the case that x equals y is true. Right? And if x equals y is true, then that implies x compared to y also returns 0. So if both of those conditions are always true for any objects x and y, then your implementation of compare to is consistent with equals. Right? Now the documentation says that your compare to method, it's strongly encouraged that compare to be consistent with equals, but it's not required. Right? So what does that mean? So that means one of these two conditions doesn't have to be true. Right? So it's not required that compare to be consistent with equals. So that means if x compared to y returns 0, right, then x equals y is allowed to return false. Right? So you have to be very careful when you use compare to, because a lot of people will use compare to, check if it's equal to 0, and then assume that the two objects are equal. That's only true if compare to is consistent with equals, right? And that's not necessarily the case. Similarly, if x equals y returns true, then x compared to y can return a non-zero value. Right? So two objects can be equal, but when you compare them, one is smaller than the other. Right? And if you think about it for a little while, so when you look at it the first time, it seems very strange. Right? But if you think about it for a little bit, it's not too hard to come up with examples where this might be the case. Right? So for example, if you have been reading the notes, you'll see that there's a playing card class. Right? So a class that represents a standard playing card. Right? So ace of hearts or something like that. When you implement equals for that class, right, a card is equal to another card if it has the same suit and the same rank. Right? So the ace of hearts is equal to the ace of hearts, and that's it. Right? It's not equal to the ace of spades. But in a lot of playing card games, you don't care about the suit. Right? You only care about the rank. So you might, depending on what you're implementing the class for, when you implement compare to, you might only look at the rank. Right? So in other words, the 10 of something is equivalent to the 10 of something. Right? So the 10 of hearts might be equivalent to the 10 of spades. They're not equal, but when you compare them, they compare to return 0. Right? So that's a simple example of when compare to might not be consistent with equals. And you can easily come up with, well, if you think about it for a little while, it's easy to come up with lots of other examples where you might choose to implement compare to so that it's not consistent with equals. Okay, so when you implement compare to, you should, instead of writing your if statement to compare the objects, you should just use one of the built-in compare methods. Right? So if you have primitive types, use the wrapper type and then the compare method for that primitive type. Right? So if you're comparing two shorts, use short.compare. If you're comparing two floats, use float.compare. Right? Don't write the if statement yourself. It's much faster just to use the method, and using the method guarantees that you're consistent with how the Java standard library implements everything. Okay, so if you implement compare to and something is wrong, right, then it becomes very hard for people who are using your class to debug what's going on. Right? Because whoever's using your class is using compare to, presumably is using your class so that they can sort objects of your class. Right? So if your compare to is broken, then anything that relies on compare to is also broken. So it turns out all of the standard sorting methods in the Java standard library, they all use compare to. Right? So when you implement a sorting algorithm, typically you compare pairs of elements. Right? How do you compare two reference values? Well, you use compare to. So any sorting type algorithm will be incorrect. Any collection that tries to sort its elements will also behave strangely. Right? So if you put objects of your type into a tree set, right, and then print the tree set, the order of the elements will not be sorted. Right? Similarly, if you use your element type, if you use your class for the key of a tree map, then your keys will no longer be sorted in the map. Right? And these are very hard bugs to detect, and they're very hard bugs to figure out what went wrong. Right? In other words, they're hard to find where the bug has occurred. Did you guys implement binary search? Yeah, so binary search, you have to compare values, right? So if you use a binary search method with objects on a list or an array of your type, then binary search no longer works the way it's supposed to. Right? And the problem with this is that it's really hard to detect, right? Because your compare to method might work most of the time, and it might only break in certain funny cases, which means you're probably not testing those cases, right, if you're testing your code at all. So you have to be very careful when you implement this method because there's a lot of other methods that depend on it. And the same is true of hash code, and the same is true of equals. Right? A lot of the standard library methods and classes depend on functioning versions of equals and hash code. Okay, compare to. So the compare to contract simply says it returns a negative value or a positive value for less than and greater than. Right? But some classes can encode extra information into the return value. Right? So the counter class is an example of where you might choose to encode extra information into the return value. Right? So if I compare two counters, then the only sensible way to compare two counters is to compare them by their value. Right? So if one counter's value is less than the other counter value, then compare to should return a negative value. Right? But in this case, you can actually return a little bit more information to the user. Right? So in the counter class, right, I'm going to change the counter class so that it implements comparable. Right? When I do that, I have to add my compare to method. Right? Now in the compare to method, I'm going to return this value minus other value. Right? So if this value is greater than the other value, right, then the value of this counter is bigger than the value of the other counter. Right? So it should return a positive value. Right? So this value minus other value will be in fact positive. If the opposite's true, right, so if this value is less than the other value, then you get a negative value, right, and that's good. If the values are equal, then the two counters are also equal, so, so this method will return 0. Right? And so this version of compare to actually encodes some extra information in the return value. Right? So it returns the difference between the value of this counter and the other counter, which might be useful for anybody using the counter class. Right? They might need to know what the difference is between the two counters. Right? So rather than forcing them to calculate it on their own, they'll simply use compare to and then look at the result. String is similar in this regard. So if you look at the string compare to method, the value returned by compare to tells you the difference between the two letters that first differ in two strings. Right? So if you compare the string A to the string B, right, then they differ in the first character, right, and they differ by 1. So compare to will return -1 in this case. Right? A dot compare to C will return -2, and so on and so forth. So it's not that unusual to find implementations of compare to that actually return some extra information that might be useful in some cases. You have to be very careful writing this. Right? It's very tempting to always write something like that. Right? Because the difference between the two things that you're comparing is often useful. Right? For the counter class, this is safe. Right? So that expression there will always give you the correct value. In general, though, you can't do this. Right? So why can't you do this in general? Oops, sorry. Right? Why can't you just write that in general? Anybody? So this value and other value, they're both ints, right? For the counter class, the value is always greater than or equal to 0. Right? If you have a class where these two values can be any int value, right, then what happens when other value is very big and negative? Yeah?
Even if you have like a negative number on the right side, it will return a positive?
Yeah, you get overflow, right? So it overflows the range of int. So if that's big and negative, right, then something minus something that's big and negative will become large and positive, right? So this will actually return the wrong sign, the value of the wrong sign, right? In other words, this object. So if the other object is smaller than this object, then you'll get the opposite result, right? It'll say the other object is bigger than this object because of overflow, right? So whenever you're implementing compare to and you are tempted to write that there, right, you have to ask yourself, can this expression actually overflow? Right? For the counter class, it can't because other value can't be negative. Right? So it's safe for this class. It's not safe for every class. All right. Any questions about compare to or hash code or equals? Anybody? All right, so equals and hash code, those are two of the important methods from the object class, right? The other one's toString. And then there are other methods in the object class, but often, for the most part, they're less commonly used. Right? So when you're implementing your own classes, it's very common to override equals. It's very common to override toString. And if you override equals, you have to override hash code. Right? So those are the big three that you need to know about. Comparable is one of the interfaces that's very common to implement, right? Because it's pretty common that you implement a class where you want to be able to sort objects of that type. So those four methods are, it's important that you understand what those four methods are, how to implement them. Okay, so moving along, we're going to talk about something called enumerations today. Oops, sorry, wrong. Okay, so enumerated types. So I've got a list of, I guess, examples here, right? And all of these examples, they seem to be there doesn't seem to be any relationship between them, but in fact, there is a relationship between them. Right? So we've got the days of the week, right? The months of the year, suits and ranks in a standard deck of playing cards, Canadian coins, provinces and territories, planets of the solar systems, arithmetic operations, the list goes on and on and on. Right? The things that what do these things have in common? So it turns out the days of the week, there's only 7 of them, right? And so there's Sunday through Saturday, right? The months of the year, there's only 12 of them, right? There's only 4 suits, there's only 13 ranks. How many coins are there right now? Pennies? No pennies, right? We got rid of the pennies. So nickels, dimes, quarters, I guess there's 5, right? Territories and provinces, planets of the solar system, arithmetic operations, right? There's all a finite number of them, right? It might be useful to create a class that represents the day of the week, or a Canadian coin, or a province, or a territory, right? But these things, they're all constants, and there's a fixed number of them, right? At least for most of these there are, right? The coins actually isn't a great example, because in your lifetime we got rid of the penny. Right? So there's actually 1 less coin than there used to be. And there probably will be, in some point, a $5 coin. Right? So coins aren't necessarily constants. Right? Similarly with the planets of the solar system, right? No one can decide whether or not Pluto is a planet or not. Right? Sometimes it is, sometimes it's not. Right? So the planets does not represent a group of constant values. Right? But the other ones, even the provinces and territories, right? Nunavut was a new territory that was made up. So even that example there is not a perfect example in this case. Right? So when you go to implement something like the days of the week or the months of the year, you should consider using what's called an enumerated type. Right? So an enumerated type is just a type whose values consist of a fixed set of constants. Right? And so all of those things there, you can argue, some more successfully than others, they all represent fixed sets of constants. The way you used to do this, so in old style Java code, and you might have seen this in C, right, is you would use int values. Right? So you'd create some constants whose type is int. Right? Now how do you do that in Java? Well, you write public static final int. Right? And then you'd give it a name. Right? So the variable Sunday in all caps would represent the day Sunday, right? And the variable Tuesday in all caps, that would represent the day Tuesday. Right? Now what's the value of Sunday? Well, it's 0. I have to give it some value because it's an int, right? What's the value of Tuesday? Well, it's 2, which is different than Sunday and Monday and every other day. Right? Now you might go ahead and do the same thing for the months of the year, right? So January we might have as month 0, February month 1, and so on and so forth. Right? And for a long time, this worked. Well, this is workable, right? It's workable. Now, the problem with doing this is that there's no type safety. Right? And so what does that mean? So that means your day or your month, they're just ints. Right? So any method that takes in an int parameter will accept a day or a month. Right? So you can call the math.max with 2 days, and it'll give you the quote-unquote maximum day, right? You can take the square root of a day, right? You can take the square root of a month, right? There's no way to write a method or a constructor where you can only pass in a day or month, right? So I can't, so when you write that constructor, what's it going to take in? It's going to take in an int, right? Are the int values only between 0 and 6 for days? The answer is no, right? You can pass in any int. Right? So now when you implement the method, you've got to do all sorts of error checking on the inputs. Right? You can do weird stuff like perform arithmetic with days and months. So I can take January and add Tuesday to it. Right? And then you can compare things, right? I can compare days and months, right? So I can compare Saturday to Sunday, but I can also compare January to Friday, for example. Right? And a lot of those things, they don't make sense. Right? And this is because you're using an int to represent the value, right? Whereas in an object-oriented programming language like Java, you should use an object to represent the value. There's another problem with using ints, in that there's no easy way to translate that int value to a string, right? So if I wanted to print out the day or the month, right, I have to write a method that looks at the value and then converts it to a string, right? In other words, there's no way I can just call toString on the int value, because you can't, int values don't have a toString method. So it's possible, instead of using ints, that you can use some other type, right? So you could use double, I guess, if you wanted to. No one does, but you could. Or you could use string, for example, right? So for the strings, if you want to use strings, I can write the string constant that represents Sunday is just the string Sunday. Right? The string constant that represents January is just the string January, right? And so this looks a little better, right? If I want to print out the month, I just call toString on the string, and I get the right string, right? But it's actually not a lot better than using ints, because you still have no type safety, right? You're still using strings to represent days and months, right? So all the same problems occur, right? Any method that takes in a string, I can now pass in a month or a day, right? The other problem is that programmers in general are very lazy, right? So when you do this sort of thing with the months, or with the days and months, the way you're supposed to use this is you're supposed to write something like day.Sunday, right? Where day is the class that, that defines these constants, right? You're supposed to write month.January. Right? But when a programmer sees that they're just plain old strings, the temptation is to just write the string constant itself, right? Because writing Sunday turns out it's a lot faster than writing month.Sunday all over the place, right? And now suddenly your code's got a bunch of these string constants Sunday, and it might have some of these, I guess these references to a class, month.Sunday, right? If you decide to change what Sunday is, so if you decide to change it to SUN, for example, right, then anybody who wrote Sunday everywhere now has to go and change all of their references to SUN as well. Right? So that's no good. And then finally, if I want to check if 2 days are equal, right, I now have to check if 2 strings are equal. Right? And checking if 2 strings are equal is a lot slower than checking if 2 ints are equal, right? Because to check if Sunday is equal to Saturday, right, I have to compare at least 2 characters of the strings before I realize that they're not the same. Okay, so to get around this problem, in the 5th version of the language, Java actually added a specific type that you can use to represent enumerated types. Right? In Java, the enumerated types, they all inherit from this class called java.lang.enum. Right? And enum inherits from the class called big O object. Right? Now, your enumerated types, they now become proper classes. Right? So, and the constants are proper objects. Right? So that means you get all the benefits of using a Java class and Java objects. Right? So your enumerated types can have fields. They can have methods, right? And they can implement interfaces. They can even have constructors, but the constructors are funny in the enumerated types. So I'll explain how the constructors work shortly. Right? So now, whenever you want to use a day, right, you really have day objects. Right? You've really got an object called Sunday. You've really got an object called Monday, and so on and so on and so forth. You can write now when you write a method that takes in a day, you have to pass in a day object, right? You can't pass in a month object because that won't compile. right? And it's very easy to make these things, right? Instead of class, you just replace class with enum. And then, so public enum day declares a enumerated type called day. Right? And then you just list your constants using a comma-separated list. Right? So in this enumeration, the thing called day.Sunday is an object that represents the day Sunday. Right? Day.Monday is an object that represents the day Monday. Right? And day.Saturday is an object that represents the day Saturday. Right? The language goes further than just giving you the constants. Right? So the language says, there shall be only one object called Sunday. Right? There shall only be one object called Monday. There shall only be one object called Saturday. Right? So in other words, the language guarantees that there's only one instance of each of these 7 objects. Right? There's only one Sunday, there's only one Monday, there's only one Tuesday, and so on and so on and so forth. Right? No one can make a new object that's also equal to Sunday. So how do you use it? Well, I mean, these are just constants, right? So you just write day.Thursday, and that gives you the object that corresponds to Thursday. Right? If you print it out, that even prints out Thursday, so you get toString for free. Right? If you want to replace toString, you can. Right? So you just override toString and return a different string for each day of the week. Right? So if you wanted to, you could override toString, and when you print out Thursday, you might print out capital T, lowercase h, lowercase u, right? So the abbreviated form, if you wanted to. Right? Otherwise, you just get the name of the constant, which is usually good enough. So this is worth repeating. So the language guarantees that the enumerated type, there's only one object for each constant. Right? And those constants are just public static final fields. Right? Now what does that mean? So that means if I want to compare 2 days, I can safely use equals, equals, or not equals. Right? I don't have to use the equals method if I don't want to. You can if you want to, but you don't have to. Right? You can safely use equals, equals. Right? Because what does equals, equals do? It checks if 2 objects are the same object. There's only one Sunday. So the only way Sunday can be equal to Sunday is if they're the same object. Right? So you can safely use equals, equals, and not equals. There are no publicly accessible constructors in an enumerated type. So that means no one else can make no one else can make additional days or months. Now, so by making enumerated types actual classes, you now get all the benefits of type safety. Right? So in other words, if you make the enumerated type month, right? Now you can write a method that takes in a month, and it will only take in one of these 12 objects. Right? If you try to pass in a day, it doesn't work. Right? It doesn't even compile, because your class, your method is taking in an instance of a month. Right? It's not taking in an instance of a day or any other enumerated type. Right? So now you get all the benefits of type safety as well. And it gets even better. So enumerated types, they implement comparable for you. So you can compare 2 instances of an enumerated type. Right? Now the one problem with this is you cannot replace the compare to method that you get. For some reason, which I don't know the reason for, you cannot override compare to for the enumerated types. The way it works for the enumerated types is that the order in which you define the constants is the order in which they compare. Right? So January is the smallest month. December is the largest month. Right? If you compare January to February, then January compares less than February. So for example, right, I've got 3 days, Monday, Thursday, and Saturday. Right? If I compare Monday to Thursday, right, so Monday dot compare to Thursday, you're going to get a negative value because Monday is less than Thursday. You also get the value -3. So it actually tells you the difference between the location of the 2 constants, right? So Monday is 3 days before Thursday, right? Saturday is 5 days before Monday, 5 days after Monday, sorry. And Thursday is 0 days after Thursday. Right? So compare to you get for free as well. Right? And now you actually get more because enumerated types, they're just objects. Objects are allowed to have information. Right? So your enumerated types are allowed to have fields, and the fields can be initialized via a constructor. Right? Now your constructors, though, are private, so we'll see how this works in a second. Right? You have to remember that the enumerated types are supposed to represent constants. Right? So you're allowed to have fields. The values of those fields probably shouldn't change ever. Right? Because your objects are supposed to be constant objects. But there's nothing from stopping you from actually changing the value of the fields. Right. So if I change month, I can modify our month enumerated type so that I also store the number of days in each month. Right. So I add a field called days. Right. It's private, so no one can access the day directly, the number of days directly. It's final because I want because the months are supposed to be constants, right? So their data shouldn't change, right? It's an int because the number of days is an int, right? Now, when you list out your constants, you also call a constructor passing in the number of days for each month, right? So January has 31 days, February usually has 28 days, right? And so on and so on and so forth, right? Now, this is calling a constructor. So that funny notation there is actually calling one of the month constructors. So you have to implement a month constructor. Right. Up here, there's my constructor for month. Now, enumerated types are a bit funny. The language says that the constructors must be private. Right. So if you put an access modifier here, you either have no access modifier or you have to mark it private. If there's no access modifier, the language makes it private. Right. The compiler forces it to be private. So that constructor is private, which means it can only be called within the enumerated class itself. Right? It doesn't do anything except assign that value to the field days. Right? And now you can also add a method to the class. Right? So I can add a method to the class that returns the number of days for a given year. Right? So for all the months except February, the number of days is always this.days. Right? So if this object is not equal to February, right, then just return the number of days. Right? Otherwise, check if it's a leap year. So that code there checks if it's a leap year. If you don't know the definition, if you don't know the actual definition of a leap year, you can just look it up. Right? So if it's a leap year, then the number of days is 28 plus 1. Right? Add 1 day, and just return the number of days. Right? So you can add methods to your class as well. And you can add as many methods and fields as you want. So in other words, an enumerated type is just like a regular class, right? Except the constructors have to be private. Okay, so enumerated types, there's extra stuff you get for free as well. Right? So you end up with a static method called values. Right? That method values returns an array of all of the enumeration constants in the order that they were declared. Right? So in other words, if I want to get an array of all of these constants, I just call the values method. Right? So in other words, month.values, right, that returns an array of all my constants. I can print them using arrays to string. Right? Well, I can get the string representation of those using arrays to string, and then print that string representation. Right? So on one line, you end up with all of this getting printed out. Right? And this lets you do other things as well, right? So now I can iterate over all of the constants and do something with each constant. Right? So for example, for every month, right? That's for every month that's defined in the enumeration, right? I can print out the month and how many days are in that month for the year 2018, for example, right? Or anything else that you want to do with that constant. Right? And so that program there will print out that list of values there. And you get more for free. Right? So it turns out you can also convert a string into one of your constants for free because the compiler generates a value of method. Right? So value of returns the constant that corresponds to that string. Right? So in other words, right, if I run month.value of May, you get the constant May. Right? So if I check is month equal to month.may, that prints true, right? If you pass in some value that doesn't correspond to a month, then you get an exception. Right? And this turns out to be super convenient too, right? When you need to generate, because it's very common that you read a file or something that defines a bunch of stuff, right? If your file defines a bunch of values for your enumerated type, then you can just read in the file as a string and convert each line, for example, into the corresponding month. Oh, this gets even better. Okay, so this is different. So you haven't seen this before at all. And you can only do this with enumerated types. Right? Every constant in your enumerated type can have its own version of a method. Right? So that sounds really wacky. Right? So every constant, right? So every one of your objects can have its own special version of a method. Right? And you're going to see how this, so later on you'll, I guess in a couple of weeks, you'll actually see the mechanism how this actually works. Right? For now, I'm just going to show you what you do if you want to do this sort of thing. Right? So if I want each constant to have its own method, to have its own version of a method, what you do is you declare an abstract, what's called an abstract method in the enumeration. Right? So let's take a look at this. Right, okay, so here's my enumeration called operation. So this represents the mathematical, the basic binary mathematical operations, right? So addition, subtraction, multiplication, division, right? Down here, you write in this line that says public, and then the keyword abstract, right? The name of the method is called apply, right? And it takes in two double values, right? X and Y, and returns a corresponding double value. So what this method does is it takes X and Y and applies one of these four operations, right? So X plus Y, X minus Y, X multiplied by Y, and X divided by Y, right? Now, when you create an abstract method, what you're saying is that, in this particular case, what you're saying is every constant has a method called apply, right? By marking it abstract, you're saying each constant will implement its own version of apply, right? So there's no method body here, right? In other words, there's no apply method for a generic operation, right? Instead, each constant defines its own version of apply, right? Now, when you define your constants, right, you can still call a constructor here if you want to, if you need to, right? But then you put in some braces, right? So the braces, these are like the body of a class, right? Inside the body, you put in the definition of your apply method, right? So apply for plus just returns X plus Y. Whoops, sorry, right? Minus for the apply version of minus just returns X minus Y. Right? And then the multiply just returns X times Y, and division just returns X divided by Y. Right? So now you can write stuff like plus. I guess you have to write operation dot plus. Oh, that's not going to work. Right? So now you can write code like operation dot plus 1 and 2, right? But you don't have to, but remember, this is just a constant, right? So you can actually store that in a variable. Right? So now you can have something like operation OP equals something, right? So for example, if you're writing a calculator program, right, you might get that something from your graphical user interface. Right? So someone presses the plus button fires back some sort of operation object. Right? Now how do you apply the operation? You just write op.apply. And then X and Y. Right? So you can do stuff like this as well, right? Which is very powerful in certain applications. Okay, so there are often times when you have some finite number of values that you want to initialize an object with, or you want to call a method with, right? Often the choice is between two different values, right? So often you'll see a method that takes in some Boolean value, right? So for example, here's a constructor for binary digit, right? So binary digit is just 0 or 1, right? So a constructor for that class might take in a Boolean value, right? So true represents 1, false represents 0, right? Here's an example of a constructor for a thermometer class, right? It's got a Boolean parameter called scale, right? You pass in true if you want a thermometer that measures in Celsius. You pass in false if you want a thermometer that measures in Fahrenheit, right? The problem is when you do this, you see code that reads something like thermometer T equals thermometer false, right? And now you have to figure out what does the false mean, right? Instead of doing that, that's a lot easier to read, right? So for someone reading the code, it's much faster to read this and understand what's going on, right? So if instead you create an enumeration that represents the two values that you want the user to be using, right? So for binary value, you might define the values 1 and 0, right? Now it's very obvious what's going on, right? Someone's making a binary digit whose value is 1, right? Someone's making a binary digit whose value is 0, right? Someone's making a thermometer whose scale is in Celsius. Someone's making a thermometer whose scale is in Fahrenheit, right? It's a lot longer to write, but you only ever write the code once, right? Someone might be reading the code, or some people might be reading the code over and over and over again, right? And this is a lot easier to read and understand than seeing something like thermometer false or thermometer true, right? Because your false and true could mean anything, right? It gets worse if there's multiple parameters that are false and true, right? So if you see something like x, comma, x, true, false, false, true, right? What the heck does that mean? Right? It's a lot easier to read that. Oh, sorry. Okay, so when should you use enumerations? You should use an enumeration when you need a set of constants and you know those values when you go to compile your program, right? So I know how many suits of cards there are. I know how many values of cards there are, right? I know the ranks for all the cards. If you're implementing chess, you know the 8 chess pieces. 8? I don't know. You know how many chess pieces there are, right? And so on and so on and so forth, right? The problem is if you don't use enumerations, you end up writing a lot of code that validates stuff, right? So if you're reading the notes, you'll see that there's a playing card class, right? The playing card class, when you first encounter it, it represents the suits and ranks using strings, right? So you have the suit hearts, where hearts is a string, right? You've got the suit diamonds, where diamonds is a string. When you go to make the playing card, you have to check if the string that's coming in is a valid suit, right? So all over that class, there's all this validation code, right? Whereas if you just made a little 4-line enumeration called suit, right? So you just do public enum suit. Right? And it's just, I guess it's just clubs, diamonds, and if you write things out in alphabetic order. Hearts and spades. Right? So this takes you like 2 seconds to write, right? And now you don't have to do any error checking anywhere in your code, right? Because the only suits that you can use are these 4 here, right? You can return the suit back to the caller as a object, right? And it becomes much easier to write the class, right? So implementing the card class using enumerations becomes way easier than implementing it if you try to use a string, right? So if you're ever in a situation where you really have a constant number of values that you know ahead of time, consider using an enumeration. It almost certainly will make your life a lot easier. All right, and I guess that will end the lecture there. And I think we're going to start part 3 of the notes, I think, next week, in the next lecture, I think. All right, so we're going to be moving on to something called inheritance in the next lecture. All right, so thanks for coming out, everybody, and I'll see you tomorrow.